Hi guys, in this video I'm going to teach you how to build C++ Steppable for CompuCell3D. So Steppable in CompuCell3D terminology means a software module, C++ module, or a plugin if you will, that runs every Monte Carlo step and performs some functions that have to do with manipulating simulation parameters. Okay? So normally this, any CompuCell3D module, either plugin or Steppable, requires a bunch of C++ and header files. And while you can use normal text editor to write those header files, this process is error prone and it takes quite a while. So we developed a nice sort of workaround, a nice shortcut, where instead of building those C++ and header files from scratch, you simply use programmer's editor Twedit, which has Steppable and plugins wizard. So let me show you how this works. So I'm in my Linux box right now, and I'm gonna type ls. So I have to start Twedit editor, Twedit++. So I'm typing with Twedit, and the editor opens. Okay. So this is the familiar editor. You use it to generate CompuCell3D simulations, right? But additionally, this editor has nice set of features which are hidden here in this menu CC3D C++. And if you open it up, the first item says generate new module. Well, this is precisely where you want to go. You open up generate new module, and a dialog pops up, and you type the name of the module. So in this tutorial we will generate Steppable. So I'm gonna call this Steppable, I don't know, let's call it cell info Steppable. And the reason why I call it cell info, because I would like in the Steppable to print a bunch of information to the screen about simulation, about cells which are in the simulation. So after typing the name, I have to specify the directory into which this cell info Steppable will be generated. Okay, so I go to browse, I go to my CompuCell3D source repository. So this is how it looks like. Okay, I go to CC3D source, I go to CompuCell3D directory, and then I go to core module here. Then from core I go to CompuCell3D, and inside CompuCell3D I go to Steppables. Okay? So since we are generating Steppables, we have to pick Steppables directory in CompuCell source tree. That's what we are doing. And as you can see, Steppable source tree has a bunch of Steppables already defined. Alright, so I'm going to hit OK. Now, the code layout. You have two options. You can either generate the Steppable in developer zone, which is sort of separate source tree for external modules, or you can generate it in the main code. Since developer zone is, it's a matter of preference. In this tutorial, I'm gonna generate code layout. I'm gonna use main code layouts. That means we'll generate CompuCell 3D module in the CompuCell3D source tree, the way it comes from Git repository. All right. In the C++ module type, I'm gonna check Steppable, right? Because I wanna generate module which runs every Monte Carlo step. Steppable. And I'm going to uncheck Python wrap. The reason why you write Steppable in C++ is because you want to have fast execution. You can write Steppable in Python, right? So normally you either write Steppable in Python when you don't really need high performance, but if you need high performance, you write Steppable in C++. And for that reason, when I write Steppable in C++, I uncheck Python wrapper, because most likely I will not need a Python wrapper for my Steppable. That's in C++. Okay. For plugins, the situation is slightly different, and we'll talk about this in the separate video. All right, so I'm gonna hit OK, and voila, there it is. So what CompuCell did, Twedit, it generated bunch of files that make up the Steppable. Okay, so we have header files for Steppable cell info. We have implementation file .cpp file. We have specifier file, which is well, I'm not going to talk too much about it. You can read a developer's documentation. And we have CMake file. And this is it. So effectively, any file in CompuCell source tree that was modified by Twedit, it's going to be displayed here. So as you can see, we have a bunch of files. We have about probably 7 files. So it's a real time saver to use Twedit instead of writing those files from scratch. Or even if you use copy and paste, Twedit will be much faster solution. And by the way, we use this functionality when we write CompuCell code, so you should too. Now, the files are generated, so we have to compile the code, right? So if you remember how to compile the code, I'm gonna minimize it for a second. I'm gonna go to CMake, okay? And in CMake, I have still open my previous compilation of CompuCell3D. Now, this directory of the source directory of CompuCell3D was modified. So we added new CMake files, we modified existing CMake files, we added new C++ files. Each time you do something to the source tree of CompuCell3D, you need to, in the CMake, you need to go to CMake, run configure, which I'm going to do now. And configuring is done successfully, so no problems. And I have to regenerate the CompuCell3D project and source code project. Okay. Now, what I've done, I have prepared new set of make files which already include the newly generated Steppable. So I'm gonna change to the console where we previously compiled CompuCell3D, and all I have to do right now is to type make. Notice that cell info Steppable was compiled, right? So we created cell info Steppable using Twedit, and after we used CMake to regenerate all the build scripts, the cell info Steppable gets automatically compiled. Right? This is precisely what we want. So right now we have our Steppable compiled. So all I have to do is type make install to install CompuCell3D. That means moving every file that was compiled, every output of the compilation to the installation directory, and that's what we're doing right now, and that's all. So let's see. Now probably is a good time to examine the content of the cell info Steppable. So the generated file does not really contain anything special. It contains probably the code that you would normally have to type anyway. So for example, C++ file has 100 lines, and yes, you can type 100 lines of C++. It's nothing intimidating, but it's what it saves you quite a lot of time. So if we look at the Steppable code, inside Steppable code, there's a function called step. So this function, just like Python step function, which you use in Python-based steppables. This function is called every Monte Carlo step. And if you look at this code, it's a demo code. What it does, it iterates over directory of cells, inventory of cells, and for each cell it prints its ID and its volume. So hopefully, when we input this, when we call this steppable from XML file, we should see the output that's coded here in C++ in our console. So let's see if this is the case. So we go to console. So I'm gonna open new tab, and I'm gonna run CompuCell3D.sh. Now, I'm gonna open a simulation file. So I'm gonna go to my home directory, demos, models, cell sort. Okay. Well, if I run it, and if I look at my console, nothing happens. It doesn't look like our steppable is working. Well, it isn't working because the simulation that we are running here, the CompuCell, the cell sort 2D, does not have steppable cell info. It has only steppable blob initializer. So all we have to do is to modify the cell sort 2D to include cell info steppable. And how do we do this? Well, we go to Twedit, we open a CompuCell3D project, open project, and this project is, I believe, demos, models, cell sort, here. Okay, so actually, let me minimize this guy. I double click. So here, what I'm going to do in XML file of the cell sort simulation, I'm going to type cell info. Oops, there's a typo. Yeah, cell info. So with this change, when I rerun cell sort 2D simulation, I should see the output in the console, which will print all the information about cell ID and cell volume. So let's see if this is the case. Where's my CompuCell3D? There it is. I'm gonna stop the simulation and I'm gonna rerun it. Look what happens. Okay? It's the same cell sort simulation. The only difference is that I've added cell info steppable to the XML file. Okay? That means that my cell info steppable, which I created using Twedit C++, is loaded to cell sort 2D simulation. Okay? Now, to show you that indeed this is real and not some magic, I'm gonna type something really silly, like hello world. Okay, so now what I expect is that my cell info steppable will print hello world, cell.id equals cell ID and cell volume. Okay, so I'm gonna save this file. After I saved it, of course, I have to let me actually close CompuCell3D GUI and let me recompile the steppable. Okay, so I'm gonna type make install, which will, as you will see, it will compile cell info steppable, and then it will install the CompuCell into target directory. So now I'm gonna go to CompuCell3D and rerun it. Okay, so I'm running again the same old simulation CellSort2D with cell info already in the XML file. Looks like I'm missing something. So that's very interesting. And I wonder what I might be missing. So let me start over. That this is the simulation I should be running. And that's very interesting what happens here. So all of a sudden I don't have output of my simulation, right? I mean, I should see information about cell IDs, but I don't. Well, and this is a good lesson. What happens is, if I go to Twedit, notice the CellSort2D XML has been modified by external program. Do you want to reload? Well, after I installed my CC3D, my CompuCell3D installation into target directory, my demos, which were in the target directory, were overwritten. That means that the file that the XML file that I modified was overwritten. So what I have to do now, I should say no and resave this XML file again and rerun CompuCell. Okay, if I do that, I get exactly what I should see. All right. So this is a lesson to you that when first of all, you should never ever run, or I shouldn't say never ever. You should copy all the demos and all CompuCell3D to be separate from the directory in which CompuCell is installed. That's lesson number one. And lesson number two, that when you play with C++, when you write C++ Steppable, yes, you get much faster code, but at the expense that you might end up in first you have to recompile the code. B, you might end up with situations like I ended up, that I accidentally overwritten some certain files, and you know, depending how quick you are, it may take you either 2 minutes to figure out or a week. So if you don't have to, Python is probably your best bet, but if you really need speed, C++ is okay, and I think that this video teaches you how to quickly build C++ Python modules. Alright, so I'm gonna stop now and I will see you at the next update.